All right, so that was a lot of math, but it's critical to understand what's going on under the hood. But I always find math is often more tractable with a good concrete example. So let's try and do forward backward with our canonical sentence, using actual probabilities and try and compute these alpha 1 n's, alpha 2 n's, and so forth. All right, so we're going to do the forward pass first, so that means we're going to compute all of alpha first, and then once we're done computing alpha, we'll compute beta, and then we'll put it all together. All right, so here's forward. So we're going to have James ate the food, and we're going to compute alpha 0n, alpha 0v, alpha 0 determiner. So this is, in that initial state, right? I observed James was emitted from this machine, and I want to know what is the probability, or what are these alphas, which is that big massive probability we saw in the previous slide, that big equation, but simplified down to this, right? Which is just the probabilities in the beginning piece of the hidden Markov model, right? Remember, beta continues on from there to the end of the sequence, and so we sort of factored the beginning half from the end half. So here's the beginning, and the beginning alpha 0n means we're going to do the beginning up to and including position 0, where position 0 is labeled as a noun. So alpha 0n says, well, I'm going to start, what's the probability? I'm going to start with an n, so that's from the initial state probability table. And then I'm going to look in my emission table and say, well, what's the probability that James was emitted given that noun was the part of speech in position 0? Right? So first I make it a noun, and then I have this emission of James. And that's all of the edges in the graph up to and including position 0, where position 0 is a noun. Which is not very much, right? I mean, we're just getting started here. All right. Of course, we have to do the same thing for verb and determiner. So let's just pretend we have only 3 parts of speech, noun, verb, and determiner. So we're going to do it for verb next. It looks exactly the same. First, I make it a verb. And then I say, what's the probability that James is emitted if the internal state of the machine is a verb? So given that I have a part of speech of verb, what's the probability of James? And you'd imagine that to be quite low. And then similarly, alpha 0 determiner, you'd say, well, what's the probability of determiner? And then on top of that, what's the probability that James would be emitted given determiner? And so these are basically that initial state probability combined with the emission probabilities in all 3 cases. All right, so that's alpha 0. Let's look at alpha 1. So alpha 1, we're saying, well, what is the score up to and including position 1, y1, being a noun? So that's this one here, right? Position 1's got to be a noun. Okay, so I can be a noun in position 1 in 3 different ways. I can either have been a noun in position 0, transitioned to a noun in position 1, and then emitted the word ate. Or I could have been a verb in position 0, transitioned to a noun, and then emitted the word ate. Or finally, I could have started in position determiner, and then transitioned to a noun in position 1, and then emitted the word ate. Right? So I don't know where I came from, right? It could have been any of these. And in some sense, because it's forward backward, I want to add up all the options, right? So I want to add up all the ones that start with noun, noun, all the ones that start with verb, noun, all the ones that start with determiner, noun. So I'm going to add these up, right? This lines up with the math we were doing earlier. In fact, this is that summation in the alpha calculation earlier. All right, so here we are. So this one here, probability of noun given noun. So this says, transition in from noun to noun. So that's this edge right here. And then I'm going to multiply that by alpha 0n. So that's basically all the ways of getting to an n in position 0, multiplied by the transition from noun to position 1. Right, so that's one way of getting there. And then times this emission. Right, so now I'm going to emit this 8 given noun. And now this P8 given noun is going to show up all throughout, so I just pulled it out front. So let's look at the second example. The second example is exactly the same thing. I'm starting this alpha 0v. Alpha 0v means how many ways, or what's the total sum of the ways to get to a verb in position 0. And then I'm going to transition to a noun again in position 1, and then finally emit the 8, right? And the emit the 8 again is pulled out front. And then finally, we're going to try starting with a determiner in position 0, and then transition to a noun in position 1, and then emit the word 8. And then we're going to do the same thing for verb, where we're going to find all 3 ways of ending up with a verb in position 1. We could have had a noun in 0, a verb in 0, or a determiner in 0. From each of those, transition to the verb in position 1, and then finally emit this 8. And then we carry on much the same way throughout the rest of alphas. Only in step alpha 2n, we're basing everything off of alpha 1n. We're saying, well, where was I in step 1? I could have been either a noun, a verb, or a determiner. So let's add up the options. From noun, I need to get a noun in position 1. That's alpha 1 noun. Then I need to transition to a noun in position 2. So that's a transition probability. And then I need to emit the word the, given that I'm in the state noun. And then that takes care of transitioning in from noun, so I got to take care of verb and determiner as well, and that's the next two terms in this summation. And then now I have alpha 2n, now I need alpha 2 verb, and alpha 2 determiner work exactly the same way, and then I carry on here doing alpha 3n, alpha 3v, and alpha 3 determiner. All right, and so once I'm done with this, I have all of the forward pass done. I filled in the alpha table. I have for each position in the sequence, I know alpha in that position for each part of speech. So I have alpha 1n, alpha 2n, alpha 3n, alpha 1 verb, alpha 2 verb, alpha 3 verb, and so on. So now I have my alpha table completely filled in. Now I need to fill in my beta table. And so this we're going to do backwards because the way the relationship worked. And so we're going to start at the end of the sequence, and from here, remember, beta says how many ways are there to continue on, say in this case, from a noun in position 2 through the rest of the sequence, right? So if I'm starting in position 2 with a noun, how do I end the sequence from here, and how do I sum that up, right? And so if you think about back to looping through that table of scored joint assignments, we're basically looping through all the ways, all the suffixes of the sequence after the one we're trying to score. All right, so here we are. So beta 3n basically says, how do I carry on from position 3? So I'm scoring position 2 as a noun, that's this one here. So I want to know, first, how do I transition from this noun to this noun? And then how do I carry on from there over to the right? And then, of course, I need to multiply by the emission probability to take care of this blue edge down, right? Right, so I factored my graph into the left-hand side, which is the alphas. The betas are the right-hand side. And so looking at the beta on the right-hand side, I'm going to multiply my alphas and betas together, if you recall from the math. So as long as I have an alpha that takes care of the left-hand side and I have a beta that takes care of the right-hand side, when I multiply it together, it's as though I multiplied everything together. So here's beta, right? So I'm carrying on from a noun in position 2. You can think of the alpha 2n is going to take care of everything up front here, everything over the James 8, and the word the up to and including this position, right? Including the emission down to the. So the alpha's already taken care of the emission down to the. So let's be careful not to double count it. And so we pick up from there. We do a transition from noun to noun, from that position, from this position 2, noun, and we transition over to this other noun, and then we emit the word food, and then we say, okay, well, then we have to carry on from there. So that's the purpose of beta 3n. That says, all right, well, now I'm I got you from position 2n to position 3n, and now I got to carry on from there. So I'm going to carry on, beta 3n carries on from there. And then what we're going to do is we're just going to work backwards, sort of one step at a time. And it works, the math looks exactly the same as alpha, only instead of saying build from the left, what did I do one step before, we're going to say, well, if I'm in this step, where might I go? I can go to any of these 3 places and add them up. Instead of saying, I had these 3 places I came from, let's add them up, right? And we're just going to work backwards, right to left. And you can see that right to left makes sense here because beta 2n depends on beta 3n, right? So I better have computed beta 3n first. That lets me build beta 2n, beta 1. And that's why it's called the backward pass, is because we do this right to left. All right. So here we are. There's beta 1n, and then finally beta 0n. And it's critical, I just want to point out one more time, right, that even though it's beta 0n, the emission we're doing is actually from position 1, right? Because we're starting at position 0 as a noun and carrying on from there. And because alpha already took care of 0's emission, we only have to take care of the transition out and then continuing on from there. So we need the transition from position 0 to 1, the emission from 1, and then carrying on from there. So that's what this is, right? This is transition out, then emit, and then carry on from there for each of the 3 positions. All right. And then, now we have alpha and beta. So we're basically done, right? So if you remember the math from a few slides back, we just multiply alpha and beta together, right? Remember we had those 2 bits, we underlined one with green, one with red. We said the green part was the part that we couldn't push the summation through, the red part was the one that we had, but the product of all of that was the answer that we wanted. So if I have alpha, which is the left-hand side, and I have beta, which is the right-hand side, and so if I have alpha, concretely in that example, we used alpha 1n and we had beta 1n. If we took the product of those 2 things, we would score y1 as a noun. And this is true for any of the other options, right? If I want to score position 5 as a verb, I would multiply alpha 5 verb times beta 5 verb. And the result of that would be the score of position 5 as a verb. And so that's all we do. We just combine them. So I want to score y1 as a noun. I just take alpha 1 noun times beta 1 noun. If I want to score it as a verb, concretely these examples. And it's proportional, right? And why is it proportional? It's because we ignored that normalizing constant down in the bottom of Bayes' rule, right? We said if we score the numerator, they'll be in the right order, if not with exactly the right magnitude. And so that's the purpose of that's the reason that you see the proportional signs here. And you can see here that this alpha 2n, if you look at the big diagram, alpha 2n basically takes care of all of these highlighted edges, right? So it's everything up to and including a noun in this position. And then the beta basically takes care of all of the edges further to the right. So this is sort of the visualization of this sort of split in the 2 pieces, right? So these are the ones that the variables of the summation have been pushed through. These are the betas from the right-hand side of the one we're scoring. And these are the alphas on the left-hand side of what we're trying to score. All right, so that's forward-backward. Viterbi is the same. Viterbi is actually the same as the forward pass. Only instead of with a summation, it's the max. Because with Viterbi, remember, this is the one that gets the joint assignment, the best joint assignment. This is the one that we naturally say is probably what people mean when they say score them all and pick the best, right? That was the Viterbi one. Score the thing, no aggregation, no adding up, just pick the highest scoring thing. And so it's basically the forward pass, as you can see here, only with a max. So instead of saying, what are all the ways I can make a noun in position 1, it's what's the best way of making a noun in position 1. And then when you get to the end of the sequence, you say, well, what's the best thing I can make in the final position? What's the highest scoring thing? That's the score of the whole sequence. And then you're done. And so Viterbi, which is maybe the more useful one, is once you understand forward-backward, is sort of a trivial modification to forward-backward. And if you ever need to write both of them, once you're done with forward and back, Viterbi is trivial. It's just a copy and paste of forward with a max instead of a for loop adding things up.